Elon Musk, the founder and CEO of Tesla, has just revealed a significant battery development that has surprised the EV industry. What components are used in the production of this new battery? How was it created? Is it price-friendly? Is this new battery technology capable of accelerating the switch from gas-powered to electric vehicles? Join me in this video as we discuss how Elon Musk recently revealed a significant battery advancement that alters everything. Regardless of the model, Tesla automobiles have a charm over their users and fans, and we can't fault these EVs for that. They are simply too talented to be ignored. The Tesla CEO, though, still yearns for better ways to increase the efficiency of his EVs. So what does he do? Invent a new battery that eliminates the need for regular battery replacements? And indeed, by adding manganese to Tesla lithium-ion batteries, he succeeded this time. The outcomes are astounding, and I believe you should take your time to learn. The tech magnate said during a speech at the Tesla Gigafactory in Berlin that manganese-based cathode battery chemistry should be investigated. This came about following a protracted search for a more effective substance that might most effectively replace nickel in Tesla batteries. The staff of the Tesla Giga plant in Berlin questioned their CEO at the meeting as to why graphene had not been explored as a possibility. You see, graphene offers various advantages over manganese in terms of extending a car's range and lowering the frequency of battery replacement. It is a mineral after all, and minerals are very common on Earth. In actuality, it would be an understatement to claim that graphene, an element derived from graphite, is abundant. Carbon is the primary component of both graphene and graphite, and it is literally present everywhere, including in large quantities in animal cages. However, the battery manufacturing business, like many others, is quite skeptical about the viability of producing batteries using graphene. He has a legitimate reason, as always, to reject something that could completely change the way batteries are made. And the reason is that producing basic graphene requires a complicated procedure which increases the cost of materials and labor. As a result, the long-term objective of lowering the price of EVs would not be achieved. Additionally, the lengthy, complex procedure necessitates a manufacturing overhaul on the part of the business. Consequently, graphene cannot be a viable alternative for Tesla in terms of time unless another simpler and faster technique is found. Discovered according to Elon Musk, the facility would first concentrate on producing iron phosphate chemistries for short-range vehicles and nickel-based chemistries for longer-range vehicles. However, this is only a temporary solution because the minerals utilized do not contribute to the $5,500 cost reduction of electric vehicles. For instance, nickel has a serious issue with price. The battery actually accounts for a sizable portion of the cost of an EV, and frequently the inflated price turns away potential consumers due to its rarity. Nickel is a very expensive element. Sadly, Elon Musk needs to manufacture EV batteries on a massive scale. The internet tycoon stated that we will eventually require tens or perhaps hundreds of millions of tons when speaking at the Berlin Gigaplant. Therefore, common materials must be employed to create these batteries on a very large scale in order to expand production. In the scaling of nickel-based batteries, we are witnessing an impossibility of the future due to their extreme scarcity. Since Tesla mainly relied on the latter for the majority of its battery minerals, the scarcity was greatly exacerbated by the Russian-Ukraine war. The tech expert suggested that the ideal solution would be to concentrate more on the minerals for the battery supply chain, and in this instance, manganese presented a better alternative. That being said, Tesla has certainly made use of manganese in the past. It's interesting to note that the business, like many other battery producers, has been employing manganese for a while with such great success that they were unable to ignore its potential. For instance, although manganese was not a very noticeable mineral, Tesla used it as one of its chemical components. However, as Musk noted, I believe manganese has some potential. He merely meant that the manganese was considerably easier to work with than the other minerals the Tesla manufacturers have been examining. It would make it possible to produce Tesla batteries in greater quantities using the same quantity of nickel in a relatively simple procedure. We can generate 50 more cell volume with the same amount of nickel by making a cathode that is 2/3 nickel and 1/3 manganese, as Elon Musk observed. The mineral will still provide a superior solution even when used in conjunction with nickel and other iron-based chemistry. However, manganese is more than what you have heard in this video. Regarding the utilization of manganese with batteries, a number of study teams have released encouraging findings. A manganese-rich cathode, according to studies, might hold the secret to achieving an energy density that is greater than the sum of nickel and iron phosphate. And what price are we discussing? Nickel. Bust batteries account for about half of the cost. As things stand, Tesla may begin to plan on cutting the $5,500 price in half, owing to manganese. However, Tesla is not finished with batteries. They unveiled a new technology that will significantly lower battery costs while also boosting mileage. Driving an IV can occasionally be difficult, especially if you don't know where or how long it will take to charge. For Tesla, having batteries that may address these issues is advantageous. So far as merging manganese and dry coating technology is concerned, Tesla will undoubtedly strike it rich. What exactly is dry coating, and how will it help Tesla make a major advancement? Watch as we reveal more information. Cost savings for Tesla cars is the primary motivation behind the dry coating concept. Some experts with strong ties to Tesla claim that the Model E's price reduction by the EV manufacturing business is only about $2,000, or about half of what Tesla plans to save for its 4,680 battery. The dry coating process is expected to further reduce this cost. Elon Musk is enthusiastic about the technology, which he calls revolutionary yet challenging. Since Tesla is not an expert in everything, it borrowed this technology from San Diego-based Maxwell Technology, which makes ultracapacitors that store energy for devices that need a quick burst of energy like cameras. Nevertheless, Tesla had to make a significant investment of $200 million to start producing 46 at dry sales this year. Maxwell and Tesla can no longer use the older, more expensive, complicated, but cutting-edge technique thanks to technology. Elon Musk naturally wants something better because the wet coating process uses a lot of technology, takes up a lot of production area, and uses a lot of labor, as well as electricity and harmful material. In a normal wet coating procedure, the components are combined with hazardous binder solvents. After the battery electrodes have been coated, they are dried in large ovens, which causes the harmful solvents to evaporate. They would be recycled, recovered, and treated, but they would also contribute significantly to the cost of production. However, dry coating greatly simplifies the entire battery production process. This is precisely what allowed Tesla to reduce the cost of its energy consumption by a third. In addition, the dry coating significantly reduced the amount of hazardous solvent needed in the production of batteries. This is due to the manufacturing skipping an intricate conventional procedure that includes a chemical slurry. According to Tesla, the global output of battery cells will need to reach 300 terawatt hours in order for the world to fully shift to a sustainable one. To make this a reality, they are taking action. Tesla will be able to create 100 gigawatt hours of 4,680 batteries annually, according to Elon Musk. It may also be interpreted as having more than enough electricity to feed the factories in Texas and Germany, as well as enough to power 1.3 million cars. By the end of the year, the EV manufacturing company is projected to build 1.4 million automobiles. However, the use of dry cells and manganese technology is still very far off. Experts will tell you that producing batteries is difficult, even for seasoned vendors. Musk acknowledges that implementing new technology can be challenging in some cases. Speaking of the manufacturing process, Elon acknowledges that scaling the production and getting considerably greater reliability and safety with the cells is the very difficult component. The challenge with applying this technique is mass-producing the batteries. Tesla currently lacks the necessary machinery to produce dry cells. And according to Elon Musk, the business is attempting to create one from scratch even though they already have the necessary tools. The chief data officer of Benchmark, Casper Rawls, warned me that it takes a very long time to fine-tune the machinery before you can start producing in large quantities. Even still, it is thought that Elon Musk's time frame in which he hopes to have these new cells by 2023 is optimistic. Making the most effective machine that can create effective dry cells for automobiles would be Musk's biggest challenge. You see, the corporation discovered a fairly significant and expensive hurdle when it approached Maxwell to develop its Tesla dry cells. Small volume batteries, which reportedly function well with ultracapacitors, are a specialty of Maxwell. Car batteries, on the other hand, are thicker and have more volume, making it challenging to coat them at high production speeds. With consistent quality, they can generate in tiny volumes, according to one source. Tesla's manufacturing was agonizingly slow, and all the promised cost reductions from the new method were lost since there were just too many rejects from the process. Yes, when properly applied, this technology will revolutionize the industry. For a Model I to be powered by Tesla, 4,400 cells of its older technology are required. The number of cells will be lowered to less than a third with the new technology. This is a blatant sign of this new technology's potential. The implementation of Tesla's dry coating technology with a manganese-based cathode will determine how effective this promising technology is.